So hey guys, welcome back to the channel Safety Talks with Gaurav. So in this video we are discussing about the Fukushima nuclear disaster, or you can say we are discussing about the case study of Fukushima nuclear disaster. So without wasting any time, let's get into the video. So the first question that is raising in your mind, what we are talking in this video. So there are some few topics that we are discussing in this video. The first one is chronology of the meltdowns, global distributions, local distributions, contaminations, evacuation, effect, diseases, health, and releases and dispensations for radioactive materials. So what happened in Fukushima nuclear disaster? So on March 11th, 2011, a huge earthquake, 14 over 46 local time, and the following tsunami, 15 over 35 local time, caused the cooling of the reactors and the cooling of the spent fuel pools of the Fukushima Daiichi nuclear plants to fail. A non-stoppable nuclear disaster unvolved. So the release of radioactive material occurred through pressure relief, uncontrolled release of radioactive steam, fires, explosions, and leakages, and seepage of hundreds of thousands of liters of contaminated water. Contrary to the Chernobyl disaster 1986, this disaster happened in multiple reactors at once, and it so so let's discuss about the chronology of meltdowns. So in reactor 1, immediately after the earthquake, radioactive gases are measured. The reactor is leaking within over the fuel due to the failure of the cooling systems, and the evaporation of cooling water melts completely. The molten nuclear fuels first accumulates at the bottom of the reactor pressure vessel. More and more holes are forming, and the bottom melts. The steam of the evaporated water forms hydrogen and oxygen, a highly volatile mix which reacts with the zinchonium alloy of the fuel rods on March 12 at 15 over 25 local time. A hydrogen explosion tears the building apart. In an attempt to solve the problem, 8,000 liters of water are pumped into the reactor per hour, but it completely evaporates or run away through the wrecked vessel into the basements. Then the chronology of the meltdown in reactor second, also a complete meltdown at 06 over 10 local time on March 11th. An explosion and a leak occurred in the containment building. A plume of radioactive white steam is seen outside the buildings. More than 10,000 of liter of water per hour are pumped into the reactor. Months after the disaster, it becomes crystal clear that the molten cores in the reactor 1, 2, and 3 lie and lava on the floors of the reactors buildings, and that further meltdowns can only be uh, prohibited by constantly 24 by 7 pumping large amounts of water into the buildings. Now now the uh, now move on the reactor number 3. The reactor also faces a full meltdown due to losses of coolant on March 14th at 11 over 01 local time. An enormous explosion dimensions large amount of the radioactive fissions products. The wind distributes them mainly in a northeast direction. There are strong scientific indications that a partial nuclear explosion of the nuclear fuel take place at this moment in the spent fuel pool, caused primarily by an hydrogen explosion. This could explain the much bigger explosion than the one that took places in reactor 1. Until today, the Japanese authorities have not released the data of the measurements that could shine a light on this issue, as one can identify scientific isotopes that only occur in spent fuels. Now move on the chronology of the meltdowns of reactor 4. So this reactor was turned off for maintenance work at the time of the earthquake, but without cooling the pond where 1331 spent fuel rods were stored. So it also heated up. The cooling water evaporated, and a hydrogen explosion occurred. A hydrogen explosion occurred at 06 over 12 local time. The building disintegrated. The rooftop was blown away, and the pond started to leak. Up to 2 lakhs 10,000 up to 2 lakh 10,000 liter of water had to be injected every day to cool the pond, which is an open air basin without any protection. The water evaporated and leaked away in the years after the reactor building was more or less stabilized by an over Overarching, yeah, it's overarching, by an overarching structure are in December 2014, all fuel rods were recovered and transferred to central interim stored storage faculty. I'm sorry, I am repeating again. Rods were recovered and transferred to central interim storage facility. At first, the authorities used helicopters to throw water into the fuel pond. However, just as in Chernobyl, this failed. Water cannons of the army and the fire brigades were used. More and more so-called concentrate pumps were added, first pumping seawater and later fresh water into the boiling spent fuel ponds to prevent the fuel rods from melting further. Now again move on to the chronology of the meltdown in reactor 2. The authorities then discovered that at a reactor 2, highly radioactive water is running uncontrolled from the reactor through a manhole into the ocean. The water has a radiation level of 1000 msv per hour. 1 hour explosion to this amount is enough to develop severe radiation sicknesses. The leak is stopped on April 6, but the water subsequently passes through several smaller leaks and keeps flowing into the Pacific to make room for even more highly radioactive water. TEPCO decided to dump to make room for even more highly radioactive water. TEPCO decided to dump 11 11,500,000 liters of water, which contained 150 billion barrels from a central water treatment tank directly into the ocean. Neighboring countries such as South Korea and China strongly protest against this act of dispersion, which is only a temporary measure as long as millions of liters of water have to be pumped into the highly contaminated buildings, and contaminated water keeps running out of those buildings into the ground and the ocean. Move on to the chronology of meltdowns in reactor 1. Remote controlled robots are sent into the reactor on April 26. They measure radioactivity up to 1120 msv per hour to illustrate the limit for German workers in the nuclear industry in 20 msv per year. At the end of April, TEPCO workers enter the destroyed reactor building and try to lower the radioactivity in the building, but installation air filters after reviewing the inspection instrument and the results of intensive measurements, the conclusion is made that there was a total meltdown of the fuel. And that there are too many holes and leakages in the building, and that it does not make any sense any more to keep flooding the reactor. So then we move on to the topic that is release and dimensions for radioactive materials. So the measurements by the Japanese government shows that in the first 6 weeks of the disaster, 42% of the total amount of cesium that was released at the that was released at the Chernobyl disaster is spread together with the highest ever releases of the radioactive noble gases, xenon. After the explosion, also the radioactive strontium up to 250 kilometers from the plants and plutonium up to 45 kilometers from the plant are measured in addition to iodine and cesium. Levels of radioactive at the site were reduced by collecting. Sorry, I repeat again. Levels of radioactive at the sites were reduced by collecting the highly radioactive debris, but values up to 10,000 msv per hour were still measured at the exhaust stack between reactor 1 and 2. All highly radioactive debris is stored temporarily on the grounds in the Fukushima prefecture. Now we move on the our next topic, that is local distribution. So the radioactive material were first blown toward the Pacific by the wind. After the explosion of reactor 3, the wind direction changed and region more to the northeast of the accidents got contaminated. Particularly high levels of radiation are measured contaminated partially high levels of radiation are measured in the soil outside the 30-kilometer evacuation zone. Large parts of Japan are contaminated for at least 3000 years, with the cesium mainly in the northeast parts of this region will remain uninhabited and unusable for agriculture. Now we move on the other topic, that is global distribution. After a few days, the effects of the nuclear disaster could be seen worldwide, all through of course extremely diluted the global system of the major points registers radioactive iodine and cesium in the atmosphere. So the release of medium and highly radioactive contaminated water direct and through the groundwater into the Pacific has already resulted in measurable exposure or marine organisms fishing of sands eels near the affected coast has been forbidden, but the radioactive particles are also spread and absorbed by algae, mussels, fish, and carps, etc. So now move on to the other topic, that is contaminations. So the area around the nuclear power plants contains highly contaminated solid. The map shows the cumulative load as an example. The maximum expected value of 1 millisievert per year (MSV per year) was exceeded 427 times in the village of Nemi until February 2015. An area of 6,000 km per square around the nuclear power plants were contaminated with about 600 kbq per meter square. The limit for permanent resettlement. The Russian authorities, after the Chernobyl disaster, the Japanese government has decided to scrap off the top layer of soil 5 centimeter depth in order to in order to reduce the radiation exposure to a maximum of 1 MSV per year. This must be done in an area 2000 square kilometers. Therefore, 100 million of cubic meters of radioactive soil has to be removed and safety stored. So now move on to the our talk. Now move on to the next topic, that is evacuation. Already on the second day of the disaster, all peoples were evacuated from a 20-kilometer radius around the nuclear power plants on day 5. And on day 5, it was decided that everyone in the area between 20 and 30 kilometers around the plant were to stay inside on March 25. A voluntary evacuation of the zone up till 30 kilometers was advised. 30 kilometers was advised. Unfortunately, most of the peoples were evacuated to regions northwest of Fukushima, the area with the highest contaminations. Around 164,000 people were evacuated from the area around the damaged reactors. Some of them were able to stay with relative or in hostels, but by far most of them have for several months lived in a major sports and exhibitions halls where they slept on the ground. In the meantime, 72,000 containers units have been built for the evacuees. Even about 5 years after the disaster, 118,000 peoples are still evacuated with a very nuclear future. So then we discuss about the our next topic, that is effects, diseases, health. So compared to the deaths caused by the natural disaster, earthquake and tsunami, the direct cases of deaths by the man-made reactor disaster in Fukushima have been very low. During the explosion at reactor 1, 4 workers were injured, and at the explosion at reactor 3, 11 workers, 1 cleanup worker died or circulatory failure. Of the tested workers, nearly 2,000 were found to be contaminated with a radiation dose above 100 MSV, a dose which causes radiation related diseases. 6 workers were contaminated with the dose for 309 MSV to 678 MSV. The information policy of tobacco and the Japanese authorities were very similar to what we have seen from the Soviet authorities in the aftermath of the Chernobyl disaster. The true consequences of the Fukushima disaster are yet to be recognized. So this is the Fukushima nuclear disaster case study. I hope you like it. If you like it, then like the video and don't forget to subscribe our channel. So thanks for watching. Thanks.